I'm just going to run through a really basic Monte Carlo simulation. We're going to simulate throwing a pair of dice, and then we want to answer the question, what is the probability that the pair adds up to 7? So for my first column, I'm just going to create an index so I know the number of trials I've done. I'm going to generate the first die, the second die, the total, and then I'm going to answer this question, what is the probability that it adds to 7? So for the first roll, I'm going to generate the first die. There are a few different ways to do this. You can use the rand function and then round, but Excel also has an integer random function, so we can just use this. We can make, we can sum these and get the total. And then we can answer this question. If this equals 7, if the total equals 7, then it's 1, otherwise it's 0. And we can repeat this a number of times. Let's repeat this 100 times. So now that we've done this, we can get a point estimate by calculating the sample mean of our y variable, and that will answer this question, the probability that t equals 7. So let's just take the average of column E. So this is our point estimate. And then we can calculate a 95% confidence interval. This is also known as the margin of error. I'm going to be using the t-score in this case, but remember that when n is large, we can use the z-score. That's an acceptable approximation. The half width, there are a number of ways to calculate this, but I'm going to use just a built-in Excel formula called confidence T. And then if you were using the z-score, you could also use confidence norm. So this is the confidence interval using a student t's distribution, and this is the confidence interval using a normal distribution. So let's use the t-score. We need to know our alpha, which let's do a 95% confidence interval. So alpha is 0.05. We need to know our standard deviation. So I'll just do it right here. The standard deviation is based on a sample, so we need to use stdev.s, not .p. So this is the correct formula to use, and this is column E. And then we want to know our size. In this case, our sample size is 100, but if I want to make this formula more dynamic, so I can increase the number of trials that I run, instead of putting in the number 100, which I can do, I'm going to just count the values in column E. So this is my half width, and then my 95% confidence interval upper bound is my mean plus my half width. My 95% confidence interval lower bound is my mean minus my half width. So now this will be the answer to this question. What is the probability that the pair adds up to 7? With a at a 95% confidence level. So this is my point estimate plus or minus my margin of error. So it's in here. And we also, in this case, it's a very simple example. We actually can calculate the true probability, which in more complex simulations and more complex models, you will not be able to calculate the true value. You won't know whether or not your confidence interval is one of the 95%, like one of the 95% of confidence intervals that is correct, quote unquote correct, for one of the 5% of confidence intervals that's quote unquote incorrect, you wouldn't know, but you're just banking on the fact that 95% of the time your true mu is going to be in this interval. But we can calculate the true probability because we know it's just 1/6. And we see that if you did this 100 times, approximately 95 of the times you would be in this range. Let's see if we can get one that is not. It's rare, but it will happen 5% of the time. Here we go. Here's one where this 95% confidence interval does not contain true mu. So it can happen. This is one way to calculate it. We can also use our formula and we can break it down. So we know we need to know the standard deviation. We know we need to know our n sample size, and then we can calculate, we know, like we can look up this t-score, but also we can use an Excel formula to look it up. And it's going to be, it's the t-distribution, and we're trying to find the inverse. And we know our probability is at the 1 minus alpha over 2 level, so it's going to be at the 0.975 level, and our degrees of freedom are n minus 1. Yeah, 1.984. I don't know why. Our t-score, so we can calculate our half-width another way, just by using our formula for half-width. And so this is the t-score times our standard deviation divided by the square root of n. And if you wanted to check, this half-width given here is going to be equal to this half-width that we calculate. This is just using a built-in Excel formula. In this case, we did the work that's, quote unquote, behind the scenes. So that's all for this very simple simulation. I hope you found this video helpful.